In this video we're going to discuss solving absolute value equations. So the absolute value technically is the distance of a number from 0. So for example, the number 5 has absolute value 5 because it's 5 units from 0 on the number line. Similarly, the absolute value of negative 5 is also 5 because it's 5 units away from 0 on the number line. So this definition of absolute value is going to be very important when we're solving equations that have an absolute value. We want to keep in mind that the absolute value of something is just its distance from 0 on the number line. So for example, if we have this inequality, absolute value of equation, not inequality. If we have the equation absolute value of x is equal to 2, we're looking for numbers whose distance from 0 on the number line is 2. So if we go 2 units from 0 in this direction, we're at the number 2. And if we go 2 units in this direction, we're at the number negative 2. So x could be 2 or negative 2. Our equations won't just have x inside the absolute value though, it'll be some function with x or some other variable, but we want to keep this image in mind here that we've drawn. The absolute value of something equal to a number means that the absolute value could be equal to, in this case it was 2 or negative 2, since the absolute value was equal to 2. So for example, if we have this equation, absolute value of 7 minus 2x equals 3, it doesn't really matter what's inside the absolute value. If you kind of cover the stuff inside up with your hand, you have absolute value of something equals 3. So you think to yourself, if I take the absolute value of something and I get 3, what could that original number have been? Well, maybe it was 3, or maybe it was negative 3. So in other words, the stuff inside the absolute value is either equal to 3 or it's equal to negative 3. So those are the two possibilities. So if we solve each of these equations for x, then we'll have our two solutions. So the two solutions are 2 and 5, and you can check those. If you substitute 2 for x, you get inside there 7 minus 4, so absolute value 3, which is equal to 3. And if you substitute 5 for x, you have 7 minus 10, which is negative 3, and the absolute value of negative 3 is 3. So a lot of times we get two solutions when we're solving these type of equations. Now sometimes the absolute value is not by itself already. And if that's the case, we want to get the absolute value by itself, and then we can use the same procedure we used in the previous example. So say we have something like this. It's very important to get the absolute value by itself because that absolute value is what dictated the process we used in the last slide. We can't take the entire left side of this equation and set it equal to 6 and negative 6 because the entire thing is not in the absolute value. So first thing we have to do is add 3 to each side. And then since it's 3 times the absolute value of x minus 6, we need to divide both sides by 3. Now that the absolute value is by itself, we can say, alright, I'm taking the absolute value of something and it equals 3. That's kind of a coincidence. The last one was 3 also. So if the absolute value of something equals 3, what could I be taking the absolute value of? Well, it could be 3 or it could be negative 3. So x could be 9, or x could be 3. All right, let's look at this equation here. We have absolute value of 3x plus 2 equals negative 3. So if you kind of start thinking through this, all right, I'm taking the absolute value of a number and I get negative 3. That doesn't make sense, right? Absolute value will always be either a positive number or 0 because it's a distance. So distance, for our purposes here, cannot be negative. So if you have an absolute value equal to a negative number, it doesn't matter what we substitute for x. We could substitute any real number we like for x, and we will never get that absolute value of something equals negative 3. So this equation has no solution. Some of our absolute value equations are going to have an absolute value on each side. So let's think about what that will mean. So if I tell you that the absolute value of A is equal to the absolute value of B, what do you know then about A and B? What could be the possibilities? So when I ask students this question, a lot of times the first possibility that they think of is, well, A and B could be the same number, right? For example, maybe A and B are both 10, and so absolute value of 10 is certainly going to be equal to the absolute value of 10. But there's a second possibility. A and B don't have to be the same number. What if A was 10 and B was negative 10? This equation would still be true because we would get positive 10 on both sides. So it could be the case that A and B are the same number, or maybe A and B are opposites. So we could write that like this. Opposites meaning the same number except one is positive and one is negative. So the example we gave was 10. A could be 10 and B could be negative 10. So another way to write that is we could write that A is equal to negative B. So if we're given an equation with an absolute value on each side, here's our two equations we can set up. One possibility is that A equals B. The other possibility is that A equals negative B. So for example, let's say we have this equation. Absolute value of x minus 6 equals absolute value of 2x plus 3. Well, from what we just discussed, we know that either the stuff inside the two absolute values is equal. So here's one possibility. Or the other possibility is that the two numbers are opposites. So on the previous slide we wrote A equals B or A equals negative B. So to indicate that here, since the stuff inside the second absolute value has two terms, we're going to need to make sure to put that 2x plus 3 in parentheses because we're taking the opposite of that entire thing. And then we can finish solving this. So the two solutions are negative 9 and 1. And if you substitute those back into the equation, it really shows why the setup is the way it is. So if we substitute negative 9 into the equation for x, we get negative 9 minus 6 inside the first one. So that would be absolute value of negative 15 on the left. And on the right, we would have 2 times negative 9, which is negative 18, plus 3, which is negative 15. So these are equal. The stuff inside the absolute value is even equal, which is what we were claiming when we set up the equation x minus 6 equals 2x plus 3. If we check our x equals 1 solution, if we substitute 1 for x in the original equation, we have 1 minus 6, so negative 5 on the left. And on the right we have 2 times 1, which is 2, plus 3, which is 5. So this is the case where the two sides are equal because the numbers inside the absolute values are opposites, which is what we wrote here.